So today we are going to understand why do elements react, and then we'll understand uh, like how do they react. The first thing is why do elements react is because the elements want to be stable. Now, what is the criteria for stability of an element is that is its electronic configuration. Every element tries to become stable by reaching or by acquiring the electronic configuration of the nearest noble gas. Right? Say, for example, if uh, now what does it mean? The noble gases, except for helium, if you look at neon, or argon, let's take these, atomic number 10 and atomic number 18 for argon. So if you'll write down the electronic configuration, you'll see that both of them have got 8 electrons. So it means that the element will become stable when their octet is complete. All right, any element will try to become stable by completing its octet, means by having 8 electrons in its outermost shell, and then they'll start resembling the electronic configuration of the nearest noble gas. But there is an exception. The exception is that in case the element has only one shell, right, then it is stable by having 2 electrons, because the diameter of the first shell is small and it cannot accommodate all the 8 electrons. So the first shell is stable with its 2 electron, and we'll say if any element has 2 electron in its outermost shell, then we'll say that its duplet is complete and the element is stable. Let's take some examples. Let us talk about the first member of the periodic table, that is hydrogen with atomic number 1. So its electronic configuration is 1. Now this hydrogen will try to have 2 electrons in its K shell, the first and the last shell. The moment it um, gets 2 electron in the outermost shell, will say that its duplet is complete and it has become stable. So this it can do either by taking, like, borrowing 1 electron from some other element, or maybe by, like, it can gain 1 electron from some element, or it can simply share the electron with some element depending upon which element it is reacting with. So this, like, completing the octet or the duplet will happen only when this element reacts with or combines chemically with other element which has the capacity to serve the need. So if you look at helium, so helium is a noble gas with 2 electrons. Its electronic configuration is 2. Its duplet is complete, and that is why it is stable. So hydrogen will also try to become stable by getting 2 electrons, means by getting the electronic configuration similar to its nearest noble gas, which is helium. Now, if we talk about the next member, lithium with 3 electron. Now, lithium has got 2 comma 1 valence. It has got 2 comma 1 electronic configuration, and there's 1 valence electron. Now, because this is the second shell where which is its outermost shell or the valence shell, it needs 7 more electron to complete its octet. So getting 7 more electron means the nucleus of lithium will have to exert that much of energy to attract 7 electron from some other element, which is difficult. So lithium will react by losing its 1 electron. So if it loses 1 electron to some other element, it will reach to a configuration of 2 only. So now the K shell becomes the first and the last shell. Now because it has lost one of the electron, that means one negative charge has reduced and one positive charge has increased. So that will give it a positive charge and will say that lithium has formed a cation or a positive ion, right? So uh, this is this is how lithium will become stable by completing its duplet. And again, we say element try to become stable by acquiring the electronic configuration of their nearest noble gas. So for lithium, the nearest noble gas is also helium, and its configuration is like that. Again, if you go to the next member of the family, which is beryllium with 2, 4 configuration, with the 4 atomic number and 2, 2 electronic configuration. So instead of gaining 6 electron, which will need lot of energy, it will lose these 2 electrons. mm, and it will form beryllium ion by losing 2 electron, and again the configuration of this element would be this ion would be 2. Okay, so let's take few more examples. Suppose we have oxygen, atomic number 8. So 2, 6 is the electronic configuration, and oxygen will become stable if it has 8 electron in its valence shell. Now this can be done by adding 2 electron or by gaining 2 electron from some other element. So when it gains 2 extra electron, it will get 2 unit negative charge and its configuration will be 2, 8, and its octet is complete, so it is stable. Again, if you look at chlorine, atomic number 17, 287. So you can see it needs just one more electron. So it will gain one electron, form chloride ion, get a configuration of 2, 8, 8, complete its octet and become stable. If you look at sodium, atomic number 11, 2, 8, 1, it will lose this one electron because that is what it can do instead of gaining 7 electron. So it will form a unipositive ion with 2, 8 configuration. Again, now this is its valence shell with 8 electron and it is stable. So elements react will react in uh, uh, will react in order to become stable. And how do we know about their stability? We will simply look at their electronic configuration. We'll see how many shells does it have. So if an element like hydrogen, helium, which have got single shell, so if the element has got a single shell, it is stable by 2 electrons. But if it has 2 or more shells, it will be stable by 8 electrons. So we'll say that its octet is complete and the element is stable. So elements can complete their octet or duplet. So this stability we know. Now this stability can be attained either by the loss of electron or by gain of electron or by sharing of electron. So the elements which are metals, like metals, well, to sum up, we can say that metals, because they have 1 or 2 or 3 valence electrons, so they will lose electron and they will become stable. The non-metals, because they have either 5 or 6 or 7 valence electrons, so they'll gain electrons to become stable, to complete their octet or the duplet. And then the metalloids, the metalloids, they will share the electron pair to become stable.